Oh, hello. My name is Gurpreet Singh, and I'll be presenting data-driven regional demand prediction for Uber. So, again, I'll be discussing business intelligence and analytical strategy, which, and again, my company is Uber Technologies. To begin with, uh, data-driven regional demand prediction for Uber. So, talking about the Uber, so it usually operates in 70 plus countries and 10,000 plus cities. It has over 131 million active monthly users. User services include ride sharing, food delivery, and logistics. As a highly data driven organization, Uber already uses analytical extensively, but there is an opportunity to optimize operations further using predictive analytical at a regional level. So, problem identification. Problem identification, despite Uber scale, the company faces a challenge mismatches between rider demand and driver availability. During peak hours or high demand zones, wait time for customers increase and drivers in low demand areas remain idle. This imbalance causes inefficiencies and lost revenue. Current forecasting models are largely static and city-wide, lacking the genuinity needed for dynamic regional level prediction. So now how we can solve it. So proposed BI analytical initiative. To address this, I propose a regional demand predictive system using machine learning models. Uber can predict demand at an hourly or regional level. Real-time dashboards will allow managers to visualize predicted demand across different areas. Automated alerts will help uh, redistribute drivers proactively to meet demand efficiently, reducing idle time and improving services. Now, the data source. Data source, the predictive model will integrate multiple data source. First thing is historical ride data from Uber's internal system, weather data from Open Weather API to account for demand fluctuations. Third is local events data from sources like Eventbrite and Google APIs, then traffic data from GPS and sensors to refine predictions, and for demographic to understand demand patterns across neighborhood. By combining these sources, we can create a robust and accurate prediction model. To continue with BI and analytical tools. The solutions will use a combination of cloud and analytical tools. Data storage will be handled via AWS or Google BigQuery. Data processing will use Python and Spark. Visualization dashboards will be built in Power BI or Tabular. Machine learning models such as Profit and XGBoost will be used for prediction. Finally, the system will integrate seamlessly the Uber's existing model and web platforms. Now, the technical workflow. The technical workflow offers or follows five key steps. First, the data is extracted and cleaned through an ETL process. Second, data is stored in a centralized warehouse. Third is machine learning models are trained and validated. Fourth, the model outputs predicted demand per region and time period. Finally, predictions are displayed on dashboards with automated alerts for operation teams to take actions. Now comes the financial implications. So, implementing this system requires initial investment. Cloud infrastructure for storage and compute is estimated as 100 grand or $100,000. BI software licenses or Tabular cost around $50,000. Hiring and training a data science team is approximately $200,000. Additionally, training and support is $30,000, and all the values are in Australian dollars. The total estimate cost for the first year is roughly around $380,000 AUD, while this is a significant investment. The benefits and ROI. Every company wants to know what's going to be the ROI. If a company is spending $1 on a training, than how much the same company can expect. So, return on investment would be the benefit of this initiative of substantially efficiency improves with a 10 to 15% reduction in idle driver time. Financially, Uber can expect an 8 to 10% increase in completed rides and revenue. Customer satisfaction will rise by around 12% due to shorter wait time. Strategically, this project strengthens Uber's data and driven decision making culture and prepares the organization for advanced analyticals in future. Now, the organizational impact. This initiative will positively impact Uber's organization. Analytical teams will collaborate more closely with operations. Managers will become proficient in using BI dashboards. The change to driver workforce are minimal because the system is largely automated. Overall, it encourages a company wide culture of data driven decision making and operation excellence. Now comes the implementation roadmap. It's easy to detect problems, is easy to have a plan, but how to implement it? So, in the implementation process, the roadmap, the implementation will occur in three phases. In the short term, from 0 to 3 months, we will focus on data collection and pilot deployment in one city. In the medium term, 4 to 9 months, the model will be trained and dashboards deployed. Finally, in a big or in the long term, 10 to 18 months roughly, the system will be scaled nationwide, optimized, and fully integrated into Uber's operations. Now, the future outlook. Future outlook, looking ahead, this initiative can evolve the emerging technologies, generative AI, artificial intelligence will provide deeper predictive insight. Sensors in vehicles can supply real-time data for even more accurate predictions, I'm sorry. Adaptive pricing models could be combined and demand prediction to maximize revenue. Additionally, predictive alerts can improve driver safety and reduce operational risks as well. Now, come to the conclusion. The conclusion is implementing a regional demand predictive system at Uber will improve operation efficiency, financial performance, and customer satisfaction. This aligns with Uber's strategic vision of smarter, more reliable mobility. This initiative is scalable, data driven, and positions Uber to lead in predictive analytical for the transportation industry. Thank you. Thank you, and that is it from my side. Thank you very much.